Hello there, Jacob here with a little anecdote from my FIRST Robotics days. Now, this was just to set the stage back in 2005. This was my first real experience using C for anything. I had a vague idea of how it was supposed to work, but as you'll see in a moment, I had some difficulty along the way. The game, as I recall, involved these tetrahedral game pieces. Now, they're shown as triangles here, but they actually have, two more legs. Well, three more legs. It's kind of like that. It's a three-dimensional, basically triangles on all sides. The objective that I had in my autonomous code here, there's 15 seconds of autonomous period at the beginning of the match, in which the operator doesn't get to touch the controls. And so you have to operate completely based on sensor data and pre-programmed instructions. So the objective that we decided that we would do is there's these game pieces, and they were held up basically just by this little magnetic doohickey at the top of the game piece. It would hold it maybe a couple of feet off of the floor, and if you knocked it down, you would get an extra couple of points. We figured that was easy enough. We had this turreted robot. It had an arm that was on a spinning turret, and there were no mechanical stops. You could actually spin this thing around and around and around, and it wasn't a very good design either, beyond the mechanical stop lack. This turret was very, very fast, as in you could do one rotation in less than a second. I can't remember how fast it was, but it was fast enough that it would hurt if it hit you. So the idea here was that we would rotate this arm, drop it down, knock this game piece off, rotate the arm back over to here where there was another game piece, knock it down as well, drive out some amount of space, and then reposition the arm back to center. Seems simple enough. I didn't know about these things called sensors yet, so I was doing it all time-based, which in and of itself isn't wrong, but it's not great either. So here's roughly the code that I had. I had a simple state machine here. So I had a state variable that I declared initially and initialized to rotate right, which was that state in which we're rotating the arm over here to the right to knock this down. We're just rotating it right, then rotating it left, then driving out, then rotating it back center. So you have all those states are presented here. Rotate right, rotate left, drive out, and recenter. So this was not exactly the code that I had. I wish I had access to the initial code that I was trying to use with this thing, but this is my recollection. This is how I've coded it, and there's a subtle error in here. Every time I would run this, every match that I would play, every match that I would play, the arm would spin to the right all the way and just smack into the plexiglass and just sit there for the rest of the autonomous period. And I kept saying to myself, what the heck? Why does that just keep happening? Why are we not proceeding on the rest of our state machine here? I kept shortening the delay that it would wait as it was rotating, and nothing. Nothing I changed seemed to have any kind of an effect. So in C, you have to know that the if statement cares only if the value in its parentheses is 0 or non-zero. So if whatever is inside of there works out to 0, it's treated as false. And the code that's inside of here is gone. Not executed whatsoever. Skipped right over. If what's inside of here is 1 or 2 or negative 10 or whatever. All of that equals true. And the code inside of here is executed. The operator that you would normally use inside of an if statement to check if two things are equal is equals equals. So to make it real simple, we'll say if 2 equals equals 2, and then there'll be some code inside of there. Now, in this case, we'll look at 2 equals equals 2 just by itself. Because 2 does in fact equal 2, this whole thing becomes 1, which is true. So this line becomes if 1, and then the code. So in this case, the code is executed. Similarly, if we go if 2 equals equals 1, we know that 2 does not equal 1, so you end up with if 0, because 2 equals equals 1, evaluates to 0, because that's false. The code inside of here does not execute. Everyone has seen something like this in their code at some point. You're taking a variable, x, and you're changing its value to 1. So this is a different concept from equals equals. These are not the same thing. This actually takes 1 and shoves it into x, whereas this is just comparing what's on the left and right side. So why then was I allowed to mix them up? Well, we're going to look at that. X equals 1, believe it or not, is equal to 1. And you can see this when you do something like x equals y equals z equals 5. This is a shortened version of x equals 5, y equals 5, and z equals 5. And the way that this happens is z equals 5 is equal to 5. So then you end up with x equals y equals 5. It'll set z to 5, then the whole thing will return 5. So in this next step, you do the same thing. You end up with that expression equaling to 5. So then you end up with x equals 5 as well. And the end result is that x, y, and z are all equal to 5. So to go back to my example, you'll see that I've made the mistake of putting equals here where I meant double equals. What I meant to say here is if the state variable is equal to rotate right, then do the stuff inside of here. After a certain amount of time has elapsed, in this case, turret half rotate time, we set the state to rotate left. This code keeps executing over and over again in a loop. So the next time it executes through, we get into rotate left and we start executing here. And then eventually we fall out and we switch into drive. The drive state gets executed. Eventually that times out and we go to the center turret state. But because what I've done here is only an equals, what I'm actually saying on this line is if rotate right. In my case, with this program, rotate right was not equal to 0. So I was saying if 1. And that means that this code right here was always executing, no matter what state was set to. So what happened was the turret was always set to 255, which in case back then 255 and 0 were the extremes, forward and reverse for a motor, and 127 was off. So I was commanding it to full forward or in this case, full right. And so it was trying as hard as it could to go to the right, and it would just sit there and camp. So the arm would just smack into the wall, and that's where it would sit. Once I figured this out and went through and put double equals all the way through my code, that's when we discovered the other problems. The arm smacked into the wall on one side, the arm smacked into the wall on the other side. The robot drove way further out than I anticipated. And then when it went to reposition the arm from this position out to here, we had that time way too long. And so it went around and around and around and around, and it ripped all the wires out of the center of the arm from the speed controllers. I was ecstatic. It was fantastic that I got this thing to work. I had been bashing my head against it for how many days and not been able to get it to proceed through all these different states. It was always stuck in this top state, and I could never figure out why. So I finally solved it. It was finally fixed. And we were disabled for the rest of the match from the base of the robot up. We could drive, but we had no control over the end of the arm. So when I came back to the pit and was jumping up and down and saying, "Oh my gosh, I fixed it! I got this all under control," the people I was working with, the other students on the team, were less than enthralled with me. So that's my story. This is Jacob. Have a good one.